Okay, I'm back, and now we want to talk about how to calculate how far an object is going to go if we know how fast it was going initially and whether or not it was accelerating. So this one up here is the how fast equation. And then off to the side here, let's write down what variables does it depend on. So notice that it's going to depend on your initial speed, it's going to depend on your final speed, it's going to depend on your acceleration, and it's going to depend on time. So notice it depends on 4 variables, and you've got to have 3 of the 4 variables in order to be able to solve for the 4th one. So now let's look at this other one here. Now, if you're one of my students, don't worry about the derivation, okay? There's the derivation above that shows where the formula is coming from. That's the algebraic way of deriving the formula. This formula can also be derived using calculus, but we're only using algebra in this class. So this is the algebraic way of coming up with this formula. And so it's going to say that the distance you travel, how far you go, is the letter R. And then it's going to depend on how fast were you going initially times t plus 1/2 at squared. So this is a really complicated looking formula because you've got to square things, you have to multiply things, you have to add things, and then also keep in mind the sign conventions. Are things going to the right or are things going to the left? And then over here, let's write down what letters go into this formula. So notice this one introduces a new variable, which is going to be, let's put it over here, the letter R. So the distance that something goes, okay, but notice it doesn't involve your final velocity, but it does involve your initial velocity, it does involve your acceleration, and it does involve time. So notice it involves 4 variables, and again, you got to know 3 of them before you can solve it for the 4th one. So let's do an example of how we might use this formula. So how far will the car in the previous sample question travel before it comes to a stop? So now we've got to go back to this one. So we had a car that was initially going at 7 meters per second, and then it hits its brakes, and we calculated the amount of time that it would take for it to come to a stop. So now let's use that information here. So we need to know how far is the car going to go before it comes to a stop. So we can't use this one because notice the letter R is not in the formula. So we've got to use this equation here. So we're going to write down the formula and then substitute into it. So we know that the car was initially going at 7 meters per second, and then in the previous problem we calculated that the time it would take to come to a stop would be 2.33 seconds. Okay, and then plus 1/2. Okay, now the acceleration, be careful. So notice that the acceleration is negative. It's slowing down. And then we need to multiply that by 2.33, but we need to square it. So lots of stuff going on in this problem. So where do we even start with this? Do not try to do the whole problem on your calculator at once, because you're going to make a mistake. So I really, really recommend that you get out a scratch piece of paper and you do the intermediate steps. So that, for example, take 7 times 2.33, and then that's where that 16.31 is coming from. And then now how are you going to do this part? You've got to start with the squared term first. So 2.33 squared, get a number, and then multiply the number by 3, and then multiply that number by 0.5, or divide by 2. And don't forget, it's a negative number, so that's where that other number is coming from. Then you need to add them together, and then you get your final result. And so that will be the distance that this car is going to travel before it comes to a stop. Okay? So next we want to talk about the hybrid equation, and we'll do that in just a moment.